This is Math 6, Lesson 3-4, using number sense to solve one-step equations. Now yesterday, or the last lesson, we talked about expressions. Now we're going to talk about equations. An equation in math is like a complete sentence in English. In English, you have to have a subject and a predicate, or a subject and a verb. In math, you have to have an algebraic expression and an equal sign making it an equation. An equation is a mathematical sentence that has an equal sign. For example, 3x plus 2 equals 7 is an algebraic equation, not necessarily an expression, because it has the equal sign. This equal sign here makes it an equation. An open sentence is an equation with one or more variables. The equation 3x plus 2 equals 7 is an open sentence because it has a variable. Until I tell you what the variable is, you cannot tell me whether or not 3x plus 2 equals 7 is a true or false equation. A solution is the value of the variable that makes an equation true. An equation is like a balanced scale. To be balanced, a scale must have weights with the same total on each side. For instance, if I had a little balanced scale, and here's my little fulcrum in the middle, if I put 5 pounds of weight here, to keep my scale balanced, I have to put 5 pounds of weight here. Otherwise, my scale would tip in one direction or the other. A true equation has equal values on each side of the equal sign. If each side of the equation does not have the same value, the equation is false. And we use the not equal sign to indicate an equation is false. And the not equal sign is an equal sign with a line through it. So let's take a look at some equations. We are going to determine whether the equations are true or false. If we look at the first one, it says 9 times 7 is 63. Well, I know that 9 times 7 is 63. 63 does indeed equal 63, so this is a true equation. If I look at number 2, 4 plus 5 equals 45. Well, I know that 4 plus 5 is equal to 9, and 9 does not equal 45. Therefore, this is a false equation. Number 3 says 70 minus 39 equals 41. Well, I'm looking at this going, okay, I know that 70 minus 39 happens to be 41. 41 does indeed equal 41, so this is a true equation. Notice none of these equations had variables. Therefore, they could either be determined to be true or false. If I would have had a variable in any of these equations, they would have to have been called an open sentence. Now, we're going to get into some basic solving equations, and we're just going to use mental math for this lesson. In the next few lessons, we're going to learn how to solve an algebraic equation by using what we call inverse operations. But today, we're just going to think in our head, gee, what must this be in order to make the sentence true? So if I look at number 4, it says 17 minus x equals 8. My brain says, gee, 17 minus what number is going to give me 8? And then I think for a minute and I go, well, 8 plus 8 is 16, so 8 plus 9 must be 17. So I'm like, oh, 17 minus 9 gives me 8. Therefore, here, x has to equal 9. All I did was think mentally. I could have also used guess and check. I could have said, well, let's see. 17 minus 10, well, that equals 7. 17 minus 9, oh, that equals 8. I could have done guess and check. But hopefully with the problems that you're going to do in this lesson, you can just think logically through them. Number 5 says w divided by 4 equals 20. So my brain says, what number divided by 4 gives me 20? And I think, well, it's got to be a fairly big number to have an answer of 20. So I'm thinking, well, I know that 80 divided by 4 gives me 20 because I know 8 divided by 4 gives me 2. So if I have 80 divided by 4, that gives me 20. Therefore, W here has to equal 80. All I'm doing is thinking mentally through the problem, saying, what must I get? And I could do guess and check if I had to, or sometimes they call that try, test, revise. It's a strategy that you can use to solve a problem. Most of what we're going to be doing in this lesson is just some mental math. Now, let's take a look at a few things. There are some open sentences that are true for every value you use for the variable. The algebraic equations that illustrate the number properties are true for all values of a, b, and c. We're going to take a look at a few properties that you should have already been introduced to but may not remember. One of these is called the identity properties. There's an identity property that says the sum of 0 and any number is that number, or the product of 1 and any number is that number. For addition, your identity property is 0. If I add 0 to something, I'm not changing anything. 0 plus 9 is 9. 0 plus a is a. What can I multiply any number by and not change my original number? That would be 1. So that says the product of 1 and any number is that number. 1 times 9 is 9. 1 times a is a. These are called your identity properties. Hopefully you will start learning some of these properties so that when I go through them later on, you'll remember them and be able to apply them. The next important property is called the commutative property. I actually talked about this a couple lessons earlier. I said the commutative property works for addition and multiplication because order does not matter. Changing the order of how you add or changing the order of how you multiply does not change your final answer. You can remember this property if you understand the word commute. Okay? Commute in English means to get from one place to another place. How you commute to school doesn't really matter as long as you get to school on time. If you live in Paulsbo, you may go down the Highway 3, or you may use a back road somewhere. It doesn't matter how you get to school or how you commute to school. The order where you go doesn't matter as long as you get to school on time. So in addition, I can add 9 plus 6, or I can add 6 plus 9. Either way, I still get 15. With multiplication, I can multiply 9 times 6, or I can multiply 6 times 9. I still get 54. And with the variables, a plus b equals b plus a times b equals b times a. The last property we're going to talk about is called the associative property. That means changing the grouping. What you put in parentheses of numbers does not change the sum or the product. Think of associative property as your group. Who do you associate with at school is your group of friends. So in arithmetic, we can put different numbers in parentheses and we can add them, and it doesn't change the final answer. If I have 9 plus parentheses 6 plus 4, that equals the same as 9 plus 6 in parentheses plus 4. For instance, if I looked at this problem, this is 9 plus 10 because 6 plus 4 is 10. That's 19. 9 plus 6 is 15. 15 plus 4 is still 19. The answer did not change. It just changed the order in which I added them. That was my grouping. That's called the associative property. Works the same with multiplication. I can take 9 times 6 times 4 and make the 6 times 4 be the first multiplication, or I can take the 9 times 6 and make that the first multiplication and then multiply that by 4. That is the associative property. You will use these properties extensively throughout your algebra career, so the sooner you understand these three properties and can commit them to memory, the happier you will be.